This is the Geometry Honors Chapter 8 review video. So let's begin with problem number 1 from the review packet. The question asks, if triangle ABC has side lengths 7, 24, and 25, do the side lengths form a Pythagorean triple? And explain. Well, a Pythagorean triple just means 3 whole non-zero numbers that actually work for the Pythagorean theorem. So in other words, a squared plus b squared does in fact equal c squared. So all we have to do is we have to take these 3 numbers and see, does 7 squared plus 24 squared equal 25 squared? Well, I know that 7 squared is 49, and I can put in my calculator 24 squared, and I get 576. And 25 squared is 625. So are those things equal? Well, let's take 576 and add 49 to it. And we do in fact get 625, which means yes, this is a Pythagorean triple. If we go to number 2, we have this picture provided for us, and it's talking about Wayne using this diagram to compute the distance from Ferris to Dunlap to Butte. How much shorter is the distance directly from Ferris to Butte than the distance Wayne found? So he's saying, I'm going to go from Ferris to Dunlap and then to Butte. But they want to know how much shorter would it be to go from Ferris to Butte directly. So the first thing I have to do is I have to find this distance right here, and I'm going to use the Pythagorean theorem to do that. 15 squared plus 20 squared equals c squared. 15 squared is 225, and 20 squared is 400. And if I add those things together, I get 625. I take the square root. C is 25. So I know this length is 25. Now, please go back and read the question again. This is very important. It says, how much shorter is the distance from Ferris to Butte than the distance he found? So the distance from Ferris to Butte is 25, but how much shorter than that, how much shorter is that than going from Ferris to Dunlap to Butte? So from Ferris to Dunlap to Butte is going to be 15 plus 20, which is 35. But from Ferris to Butte is only 25. So my answer is 10 miles shorter. So please make sure you read the entire question and give them exactly the information that they are asking for. Number 3 says a triangle has side lengths of 15, 23, and 28. Is it a right triangle? So what I have to do is I have to see, does the Pythagorean theorem work? So is 15 squared plus 23 squared equal to 28 squared? That's what I want to know. So 15 squared is 225. 23 squared is 529. I want to know, does that equal 28 squared, which is 784? So I'm going to take 529 plus 225, and that gives me 754, which is not equal to 784. So I know that this is not a right triangle. Number 4 is similar. It says you have a triangle with side lengths 4, 3, and 5 centimeters. Classify it as acute, obtuse, or right. So again, I'm going to do the Pythagorean theorem, but I need to compare these values. So I've got 4 squared plus 3 squared. I want to know, what's the relationship? Is it equal? Is it going to be less than 2, greater than 5 squared? So I get 16 plus 9. It's going to be some relationship to 25. And when I do my math, I find that 25 is what is equal on both sides, so this is a right triangle. And we're going to do number 5. Number 5 is very similar again. I have to set up the same type of thing, so I'm going to take 20 squared plus 13 squared equals 26 squared. Now, what's very important is that you make sure you always take the longest measure, and that's going to be on the right side of your equation. That's your C value. So your longest side, you always have to put on the right side by itself. 20 squared is going to give me 400. 13 squared gives me 169. And 26 squared is going to give me 676. So I want to know what's going to be the relationship here. 400 plus 169 gives me 569 compared to the 676. So I know my hypotenuse is larger, and because my hypotenuse is larger, I know that means that I have an obtuse triangle. So number 5 is an obtuse triangle because my hypotenuse is greater than the sum of my other two legs. And then lastly, we have number 6 on this slide. In triangle ABC, angle I is a right angle, and you can see that they give you that information in the diagram. And angle B is 45 degrees. Well, they give it to us here, but they don't draw it in the picture, so I'm going to write that information into my picture. I always label my picture. I want to find BC. If your answer is not an integer, leave it in simplest radical form. Okay, so 45 degrees. We learned something about 45, 45, 90 triangles. And it's a hint to me that I need to use it because it says use simplest radical form. And I know that the rule, this is on your reference sheet, remember, is whatever my two sides are in a 45, 45, 90 triangle, I know that my hypotenuse is going to be the side times radical 2. So in this case, if my side is 12, then side BC is going to be 12 radical 2 feet. So I'm just taking my side, I'm multiplying it by radical 2. Remember, that's on your reference sheet, but you need to be able to recognize when and how to use it. All right, for problem number 7, this is similar to the last problem we did, except we're going the other way from the hypotenuse, to the sides. So I want to take this 12, and I want to break it down to figure out what each of my sides is going to be. Well, the trick here is take this 12, cut it in half, so divide it by 2, and then add a radical 2. Not add, like attach it to the end of the number. So your side lengths are going to be 6 radical 2. If you do not remember these simple tricks, you can always use trigonometry. You could just say that you need to find x, which is one of the sides, using the angle 45 and the hypotenuse. So for question number 8, I'm going to sketch a picture here. It's talking about a square garden. So I'm going to draw my square garden with area 72 meters squared. So first of all, I know that with a square, when I take the area, it's going to be whatever my side is squared. And in this case, my side squared has to equal 72. So if I take the square root of that, I can determine that my side is equal to 6 radical 2. So each of my sides is 6 radical 2. But in the question, they ask you to find the length of the diagonal. I know that this is 90 degrees here, and when I put this diagonal into my square, I'm creating a 45, 45, 90 triangle. So I can use my simple rules, or I can use trigonometry to determine what the length of that diagonal is. If my side is 6 radical 2, in order to get to my hypotenuse, I have to take whatever my side is and multiply it by radical 2. So 6 radical 2 times radical 2 will give me 6 times 2, which is 12 meters. So 12 meters is the length of your diagonal for this problem. Now for number 9, this is a really tricky problem. It's asking you to find the length, d, in simplest radical form, of the diagonal of a cube with sides s units. Okay, so first thing I'm going to do is I'm going to sketch out a cube. And sketch it down here in this empty space. This is not going to be a perfect cube, guys, but it'll work. And they want us to find the diagonal of that cube. So let's draw that in a different color. Going from this corner right down here up through the cube. So slicing diagonally through that cube, that's the length they want me to find. Now, through this entire chapter, we've learned that triangles are really super, super helpful. So what I'm going to do is I'm going to create a right triangle for me to use to help me solve this problem by using one of my sides and then that diagonal right there going through that bottom face. So now I have a right triangle, and they told us in the problem that this cube has sides of s units. So I know this side is s, but I also know then that all of the other sides are s, which means my diagonal must be s radical 2. And that's from your 45, 45, 90 triangle. It's on your reference sheet. If each of your sides are s, then your diagonal of that bottom face must be s radical 2. So now I have two sides of my red triangle there, which is going to help me using Pythagorean Theorem to find the length of my diagonal. So I'm just going to set up s squared plus s radical 2 squared equals the length of the diagonal squared. So s squared plus, well, when I square s radical 2, the s right here becomes an s squared. And the radical 2, when I square it, becomes just the number 2. Now these are like terms, so I can combine them to get 3s squared equals my diagonal squared. I'm going to take the square root to figure out that my diagonal is just s radical 3. And that s radical 3 came from the fact that I know square root of s squared is s, and then square root of 3 that's just going to remain square root of 3. So that is your answer for 9. That is a very tricky problem, but please make sure that you understand and know how to do that problem. Now for number 10, it's asking me about a 30, 60, 90 triangle, but it's asking me to find the perimeter. So I actually have to take another step when I'm done with this problem. I'm going to sketch out my 30, 60, 90 triangle. So there's my 30, 60, 90, and they told me that my hypotenuse is 7. Now you can either use trigonometry to find these two sides, x and y, or you can use the tricks that are on your reference sheet because we know all 30, 60, 90 triangles have the same pattern that they follow. So I'm going to go ahead and do it that way because we'll get to trig later. But if I know my hypotenuse is 7, then hypotenuse means to get to my short side, I just need to cut it in half. So 3.5. Then I know in order to get to my medium side, or my methodium, I need to take that 3.5 and I need to multiply it by radical 3. So what I'm going to do is I'm going to combine my 7 and my 3.5, which gives me 10.5. And then I'm just going to say plus 3.5 radical 3. Because I don't want to get a decimal approximation of that. I want to leave it in simplest radical form. Now, please just know that you can put that in your calculator and it will give you a decimal approximation in case your answers on your multiple choice test are in decimal form, or if they tell you to round to, say, the nearest tenth. You can just plug this into your calculator. But I'm going to leave the answer like that. All right, so for number 11, I see again that I have a 30, 60, 90 triangle, and I'm looking for the values of x and y, which are my short sides and my medium sides, and the directions say to leave in simplest radical form. So I know I'm using my little tricks that are on my reference sheet. To go from my hypotenuse to my short side, I'm going to cut that value in half. So y is going to be equal to 14 radical 3. And then to get to my medium side, or my methodium, and I'll write down hypotenuse as well. To get to my medium side, I need to take the 14 radical 3 and multiply it by radical 3. And what that gives me is my radical 3 times my radical 3 turns into just the number 3. I multiply that by 14, and I get 42. So x is 42. and y is 14 radical 3. For 12, we're starting to get into trigonometry. It's asking you for the tangent ratios for angle P and angle Q. So first of all, let's write down SOHCAHTOA. In this problem, we're concerned with tangent, which means we need the opposite over the adjacent side. So if I look at angle P, I'm going to draw my person standing there in green. My opposite side is 8, and my adjacent side is 6, which simplifies down, if I divide by 2, to 4 over 3. And that is the tangent of P that we just calculated. So now we can look at tangent of Q. If I draw my person standing at Q, opposite is now 6, and adjacent is now 8, which reduces to 3 over 4, and that was the tangent of Q that we just found. All right, so here we're using trigonometry to find the value of x. For this first problem, I'm going to draw my person standing at the 30-degree angle mark that they've given us. And when I look around my triangle, I see that they've given me my opposite side is x, and my adjacent side is 6. And I know using SOHCAHTOA that if they give me my opposite side and my adjacent side, I need to use tangent. So I set up my equation. Tangent 30 equals opposite over adjacent. And when I have my x being in the numerator of this fraction, I need to multiply tangent 30 times 6. Now when I write that down, I get 6 tangent 30 equals x, and that's exactly how I type it into my calculator, 6 tangent 30. And when I round to the nearest tenth, I get 3.5. Now I'm going to do the same thing down here for number 14. Draw my person at 30 degrees. I see that my adjacent side is x and my hypotenuse is 15, but they don't give me any information about my opposite side. So when I have a and h looking up here, I see I use cosine. So cosine of 30 equals adjacent over hypotenuse. Again, I'm going to multiply these two things. So in my calculator and on my paper, I have 15 cosine 30 equals x. And when I round that answer to the nearest tenth, it was 12.99. My answer becomes 13. All right. A slide 4.1 meters long makes an angle of 35 degrees with the ground. To the nearest tenth of a meter, how far above the ground is the top of the slide? So they give me this word problem, but they've also given me this diagram. Let me tell you that you're not always going to be provided with the diagram, so make sure that you understand where these values come from. The slide is this diagonal, which is my hypotenuse, which is 4.1 meters long, and it makes an angle with the ground of 35 degrees. They want to know to the nearest tenth of a meter, how far is the top of the slide from the ground? So I'm going to use my trigonometry, draw my person at 35 degrees. My opposite side is x, and my hypotenuse is 4.1. So using SOHCAHTOA, I know I'm using the sine of 35 degrees equals x over 4.1. So I'm going to multiply these two things. So I have 4.1 sine 35 equals x, and I type it into my calculator just like that. And when I round to the nearest tenth, I get x equals 2.4 meters. All right, here we've got a word problem. The students in Mr. Collins' class used a surveyor's measuring device to find the angle from their location to the top of the building. They also measured their distance from the bottom of the building. The diagram shows the angle measure and the distance. Okay, so they've given you a diagram. This says 72. This is 100 feet. To the nearest foot, find the height of the building. So this is what we're looking for. So I'm going to write the variable x in there. And if I draw my person at 72, I see that my opposite side is x, my adjacent side is 100 feet. So I know I have to use the tangent of 72 degrees, and that's going to equal opposite over adjacent. So again, I multiply these two things. So I need to type into my calculator 100 tangent 72 equals x. When I type that in and round it to the nearest foot, I get x equals 308 feet. Now for 17, it says a large totem pole in the state of Washington is 100 feet tall, and at a particular time of day, the totem pole casts a 249-foot-long shadow. They want us to find the measure of angle A to the nearest degree. So I'm looking for this here. So that's where I'm going to put my x, right there at that angle. Now remember, I can find an angle in a second. So I know I'm going to have to be thinking about the second button. But first, I look around and I see that I have my opposite side and I have my adjacent side. So I know I'm going to be using tangent. So tangent of x, because I don't know what angle it is, equals opposite over adjacent. So now when I put that into my calculator, I have to hit second tangent, which is going to look like tangent inverse in your calculator, and then you hit 100 divided by 249. And then the answer that you're going to get when you round it to the nearest degree is that the measure of angle A is equal to 22 degrees. All right, for problem number 18, this picture didn't come out very well, but what I'm going to do is just have you say that this thing right here is a tower. We're just going to call it a tower. That's all we're going to call it. So what is the description of angle 1 as it relates to this situation? Well, angle 1 is right here, and I see that it's an angle below this horizontal line, which tells me it is an angle of depression. And if I'm looking at where it's coming from and where it's going to, it's coming from the airplane, and it's going to the tower. So that's all. You just have to explain that it's an angle of depression because it's below the horizontal line. It's going from the airplane to the tower. Now, an angle of elevation, remember, is something above the horizontal line. So say like angle 2 would be an angle of elevation. So would angle 4. For number 19, I'm being asked to find the value of x, round to the nearest tenth. So again, I'm using trigonometry here. So I draw my person at 36 degrees. I do not have my opposite, but I have my adjacent and my hypotenuse. So cosine is what I'm going to be using. Cosine of 36 degrees equals adjacent over hypotenuse. So I take those two things, I'm going to multiply them. In my calculator, I'm going to type 7 cosine 36 degrees. That's going to equal x. And it says to round to the nearest tenth. When I do that, I should get 5.7 feet is equal to x. Okay, again, I'm looking for the value of x, and I'm going to round to the nearest tenth. So let's draw our person at 35 degrees. We have x is our opposite, and 7 is our adjacent. So we're using tangent of 35 degrees equals opposite over adjacent. I'm going to multiply those two things. And when I put 7 tangent 35 into my calculator, I'll get x equals 4.9 centimeters. All right, so number 21 is a little bit different because the angle that they gave me is outside of my triangle. So there's two things I can do. First of all, I can recognize that this is going to be alternate interior angles, so that angle is also 40. Or I could recognize that I have to have a 90-degree angle here, which means this remaining angle is 50 degrees. Now, you can use either of those angles to calculate the value of x. I'm going to use the 50. So I'm going to draw my person at 50. And I see that I have opposite is 12 yards, and adjacent is x. So that means I need to use tangent of 50 degrees equals opposite over adjacent. Now, since my x is in the denominator of this fraction, I need to switch these two things, completely switch them. So I have x equals 12 divided by tangent of 50. I'm going to put that into my calculator and round to the nearest tenth, and what I should get is 10.1 yards. Now for number 22, I have this word problem. It does not give me a diagram, so I should probably draw a diagram for myself. So a spotlight is mounted on a wall 7.4 feet above a security desk in an office building. It is used to light an entrance door 9.3 feet from the desk. Okay, so let's start drawing our picture. I have a security desk in this office building. Here's my little man sitting at the desk. And there's a security camera mounted on the ceiling. It's 7.4 feet above that security desk. And it's used to light an entrance door 9.3 feet from the desk. So this is my door, 9.3 feet from the desk. To the nearest degree, what is the angle of depression from the spotlight to the entrance door? So I want to know if this is, oh, I'm sorry, that's a spotlight. It's not a video camera. So if I have a horizontal line here, and I'm going from the spotlight to the entrance door, I want to know the angle of depression. So that's this right here. That's what I'm looking for. But that's not within my triangle. So what I think I'm going to do is say if that's x, then this angle is going to be the exact same, and that is within my triangle that I formed. So I'm going to find this, which in return is finding me the answer to my problem. Okay, so that's where I'm going to draw my little man so I can look around my triangle. I have my opposite is 7.4. My adjacent is 9.3. So opposite and adjacent, I know I'm using tangent. So tangent of whatever my angle is equal to opposite over adjacent. Now when I put that into my calculator, remember, I can find an angle in a second. So I have to sit second, then tangent. Okay, and it's going to come into my calculator as tangent inverse. I type in 7.4 divided by 9.3. And what I get is 38.5, which really means that this angle, which we've labeled x, is 39 degrees because we're rounding to the nearest degree. All right, for this problem on vectors here, says a glider lands 17 miles west and 6 miles south from where it took off. The result of the trip can be described by the vector -17, -6. They've drawn me this picture here. They go left 17, down 6, and they create this vector. Use the distance for magnitude, so I need to find this length here, and direction to describe this vector a second way. So I need to find two things. I need to find this angle x, which they've labeled for me, and I also need to find this side here. We're going to call it m for magnitude. Now m I can find pretty easily by using Pythagorean Theorem. So remember, your side lengths are always positive. Even though they've given you this is -17, that's because they went left, but the actual length of it is 17. Same with this 6. So I'm going to take 17 squared plus 6 squared, and I know that that's going to have to equal my magnitude squared. I need to put 17 squared into my calculator. That gives me 289. And I know that 6 squared is 36. So when I add those two things together, I get 325 equals m squared. If I take the square root, I get 18.0277. So what I'm going to do is, since that's so close to 18, I'm just going to say it's approximately 18 miles. That's my magnitude. And then the other thing I have to do is I have to find that angle. So let's draw our person at that angle. If you're looking around the triangle, you have your opposite side is 6 and your adjacent side is 17. So that means you're using tangent of whatever the angle is, x, equals opposite is 6 over adjacent is 17. And remember, you have to use second tangent to find this. So when I plug it into my calculator, I get that x is 19 degrees. And that's rounding to the nearest whole degree. It was 19.44, and I'm rounding it to the nearest whole degree. Okay, so 19 degrees. The only other thing I have to clarify is which direction is this going to be. So 19 degrees, I know it's southwest something, right? Because I'm in between south and west. But I need to figure out, is it south of west or is it west of south? And the way I do that is I see that my vector is, it's part of west, right? That's one of my side lengths is west. And what I'm going to do is I'm going to move a little bit south of that west. So that's how I write it. I say 19 degrees south of west. And my magnitude is 18 miles. All right, so here I just need to find my resultant vectors. And they've already given me the coordinates here of the other two vectors. So all I have to do is add those numbers together and stick them into a set. Let me get a smaller pen here. Stick them into a set of these like pointy bracket parenthesis things. So I'm going to take 5 plus 0 is 5, and negative 2 plus 0 is negative 2. That's my first answer. Done. That's simple. Second one, negative 6 plus 6, I get 0. And 5 plus negative 5, I get 0. So that's my second resultant vector. That's it. So I'm on to my last two problems here. I have a word problem. Miguel is driving his motorboat across a river. The speed of the boat in still water is 9 miles an hour, but the river flows directly south at 3 miles an hour. So if Miguel heads directly west, what are the boat's resultant speed and direction? Okay, so again, this is similar to like two problems ago. I need to find two things. I need to find x, and I need to find my magnitude here. So let's take 9 squared plus 3 squared. That's going to equal m squared. So 81 plus 9 equals m squared. 90 equals m squared. And I need to take the square root. So that's going to go into my calculator, and I'm going to get 3 radical 10. Okay, so 3 radical 10, maybe they want a decimal. It doesn't specifically say. So you're just going to have to kind of check the multiple choice answers on that one as well. But that's my magnitude. The only other thing I have to find then is my angle there, this missing angle x. So if I draw my person and I look around my triangle, I've got my opposite side and my adjacent side. So I'm going to use tangent of x equals opposite over adjacent. So again, I can find an angle in a second. So you have to hit second tangent and then 3 divided by 9. When you do that, you'll determine that x to the nearest degree is going to be 18 degrees. Now the only other thing I have to clarify is I have to clarify that this is going to be south of west. For that same reason, my triangle is sharing the west line. So I'm going to have something of west. If my triangle went a little bit north here, it would be north of west, but here I have south of west. This is originally where I was, and I veered a little bit south. And my last problem here is two parts. First it says, write the resultant as an ordered pair, and then it says, draw the resultant. So I'm sorry this is such a poor quality image. You guys should have it much better on your review packet itself. But I can see that my two vectors are like here and here. First thing I have to do is I have to figure out the coordinates of those vectors. So this first one is 1, 2, 3, negative 3, 4. I'm going to write that over here as well. Negative 3, 4. My second vector is negative 5, negative 1, it would appear. And negative 5, negative 1. So when I find the resultant, I'm just going to add up my x's. So I get negative 8. I add up my y's. 4 plus negative 1, I get 3. And then that is part A. That's my resultant vector as an ordered pair. But I also have to draw that in. So I'm going to use a different color. I'm going to use blue. I'm going to draw in negative 8 would be about here. Up 3 is about here. So that's my point. That's going to have to be the tip of my arrow, and it's going to connect back to my origin. Draw the tip of my arrow. So that is my resultant vector. All I did is I plotted this point, negative 8, 3, and then I connected it back to the origin and put an arrow on the end, making it a vector. So there you have it. The entire packet has been gone through. If you have any questions, you can email me and I'll try to get back to you as soon as I can. But please go back, rewind this, pause this, rewatch problems that are confusing to you, and make sure that you are prepared for your test.